All right, in this lesson, we are going to talk about something called the sum and product rule, which can be used to write quadratic equations. And so given the x-intercepts and the a value of a quadratic function, write the equation in standard form. And so reminder, standard form is ax squared plus bx plus c. Okay, and if we're given the x-intercepts, we're going to have to start with root form. And so this is one of our roots. That is our other root. So if our roots are -3 and 5, we have to start with root form, which root form is, you still have that a value, but x minus one of your roots, x minus the other root. So you're going to see the opposite of those roots. And so for root form, our a value is 1, so I'm not going to write the 1. And then we would have x plus 3, x minus 5. Okay? And so in order to get to standard form, we just have to FOIL this out. So we would get x squared minus 5x plus 3x minus 15. Okay? And so combining our like terms, we would get minus 2x minus 15. Okay, and so our standard form is y equals x squared minus 2x minus 15. Okay, for this next one, our roots are 2 and 8, and then our a value is -3. So in root form, we would have y equals a x minus the root, x minus the other root. Okay, and so when you're FOILing this out, FOIL, then distribute the -3. So we would get x squared minus 8x minus 2x plus 16. Okay, and so combining our like terms, x squared minus 10x plus 6. Okay, and then we still have that -3. And so put this expression back in parentheses because you can't just put the -3 in front. You have to distribute it to all 3 places. And so my final answer would be -3x squared plus 30x minus 18. Don't forget to distribute it to all 3 places. Okay, and so this would be our standard form. Okay, and then for this last one, we would have our root form, a x minus 1 root, x minus -3 would be x plus 3. So in this situation, usually I do not distribute first, but you can if it will help get rid of this fraction. So I'm actually going to distribute the 4 first. The trick is when you are distributing it, you can't distribute it to both parentheses. If you distribute to both, you've basically distributed a 16 instead of just a 4. And so only distribute it to one of the parentheses. And I'm distributing it to the x minus 1/2 because that gets rid of the fraction. 4 times 1/2 is 2. Okay, and so now we have integers that we can work with. 4x squared plus 12x minus 2x minus 6. Combine your like terms. We get y equals 4x squared plus 10x minus 6 for our standard form. Okay, and so this was a review. We haven't talked about the sum and product rule yet because we haven't really needed it. If we have real integer roots or even fraction roots, we can write root form and then convert to standard form. The difficult part is when you have complex roots. Okay, you're not going to want to write your root form using complex numbers, especially when square roots are involved. And so that's when the sum and product rule comes into play. And so if you look at our first example, looking at the -2 and the -15 in relationship to our roots were -3 and 5. Okay, if I add, which is sum, if I add the roots, I would get -3 plus 5, which equals +2. If I multiply, which would be their product, -3 times 5 is -15. Okay, and so the sum and product rule says that your B value is always going to be the opposite of the sum. Okay, the opposite of the sum. That's what that minus sign here means. So that's one thing a lot of people forget. So minus 2x. And then the last term will always be the product of your roots. And don't change the sign. You keep it exactly the same. So my product was -15, and I see a -15 here. Okay, and so you can see that here before we distributed the -3. If I add 2 plus 8, I get 10. And we have a -10 here. If I multiply the 2 and the 8, I get 16. And we see, oh no, I messed that up. That was a 16. And then that should have been a 38 or 48. Good way to check your work. Okay, and so the sum and product rule. And so that's what we're gonna do when we have complex roots. And so if a quadratic has a root that's complex, like a plus bi, his conjugate, a minus bi, is also a root because the formula the quadratic formula has the plus or minus. Okay, and so given one x-intercept of a quadratic function, write the equation in standard form. Okay, so one of my roots is -1 plus 5i, so I know -1 minus 5i is also a root. And so from there, let's figure out the sum, which is -1 plus 5i plus -1 minus 5i. Okay, and so if we add the real parts, -1 plus -1 is -2. And then 5i plus -5i is no I. And so you should get real numbers for the sums and products. So our sum is -2. And then our product, because it's a conjugate, it will also be a real number. And so the product is -1 plus 5i and -1 minus 5i. And so when I FOIL this out, I get +1 plus 5i minus 5i minus 25i squared. Middle term cancels. I squared is the same as -1. And so I end up with 1 plus 25, which is 26. So the sum is -2, the product is 26. And so by the sum and product rule, we have x squared minus the sum, which is -2. So this is going to end up being +2 with the x, and then my constant term is the 26. So make sure you do opposite for your b value for the sum. Okay, for this next one, I have 2 minus I root 3, and so 2 plus I root 3 will be my other root. Starting with the sum, 2 minus I root 3 plus 2 plus I root 3. 2 plus 2 is 4, and then the imaginary parts cancel. So my sum is 4. So I know I have x squared minus 4x. And then we just need to find the product to get that constant c value. So 2 minus I root 3 times 2 plus I root 3. I have 4 plus 2I root 3 minus 2I root 3. And then plus or minus negative I times I is negative I squared. Root 3 times root 3 is root 3 or root 9. You multiply the numbers under the radicals. Okay, and so these cancel, leaving me with 4. I squared is the same as negative 1. So plus, and the square root of 9 is the same thing as 3. So 4 plus 3 is 7. And so the constant is 7.